Hello everybody, welcome back to another video. And in my previous video, we looked at taking the derivative of the inverse sine of x using implicit differentiation and then eventually a method to simplify an inverse trig function inside of a trig function. So what we'll do now in today's video is take the integral of the inverse sine of x. And you may be asking, how do we do this? Because we only find the derivative, so how do we take the integral of this? We only have this function and nothing else to work with. Well, the first thing that we can see is that in a lot of cases with integration by parts, we use the fact that this expression is the same thing as the inverse sine of x multiplied by 1. And because of that, we have a product of two functions, and we can use integration by parts. And whenever we're in a case where we have a function that we don't know how to integrate and it's by itself, we'll need to use that method, because we see that taking a u sub here does not help us yet, because we have of course, taking the derivative of the inverse sine of x is this, but this won't help us in any way as of now. And what we'll have to do is we'll have to use the di setup. So this is now, let's take the derivative of course, the inverse sine of x, because that's the only thing that we know how to do. And then let's integrate 1. So integrating 1 in the x world is just going to be x, and remember we have a plus and a minus here. Now, what we do with the di setup, it's essentially the exact same thing as integration by parts, but just setting it up in a more visual way or in a table-based way so that we can just draw some arrows and see what our products are. So what we need to do here is we need to take the derivative of the inverse sine of x. So that we know is our 1 over the square root of 1 minus x squared. Now what we do is we take the product of the diagonals, and we see that here we still have this last row. So what we do is we take this last row as a product, but we take the integral of the product of the last row. So this right here is an integral, and we see that how this is the exact same because we have a uv minus now, because this minus is here, the integral of v du. So we have x, so we see that now the integral of the inverse sine of x dx comes to, we have now x multiplied by the inverse sine of x, and then we have a minus the integral of v du. So that would be, of course, this product of the last row, which is x over the square root of 1 minus x squared dx. So where do we go from here? Well, the first thing we can see is that we have a nice setup for a u sub, because we have an x squared on here, and then we have an x in the numerator. So that is pretty nice. So why don't we try taking a u sub, set u to be this entire expression in the square root, in the radical, and see that, so here u is 1 minus x squared. Now taking du, we have to take the derivative of, now just 1 is just 0, and then negative x squared, we still have that negative, and then derivative of x squared is 2x, our favorite power rule. And then what we see here, because x, we have to multiply the derivative of x, which is dx. Now we need to isolate for dx. We see that dx is negative du by 2x. So we see that here we have a negative 1/2 multiple, which we can take out of this integral, and the negative 1/2 with this negative will become a positive 1/2. So we see that this is equal to x multiplied by the inverse sine of x, and then we now add the integral, and now we're in the u world. So we have let's just take the 1/2 multiple out as well. So we have what, plus half of the integral of, and then we have x over, and then the square root of u. That's pretty nice. And then what is our dx? Our dx is negative du by 2x. We took the negative 1/2 out, so we just have du by x now. And yes, that is absolutely perfect, because what we see is that this x and this x cancel. We have no more x's, and we're completely in the u world now. So we see that this is equal to x multiplied by the inverse sine of x plus 1/2 multiplied by the integral of 1 over the square root of u du. So how do we do this? Well, this is a pretty standard integral, because what we see is that u, the square root of u, is the same thing as u to the 1/2 power. And we know that 1 over anything is that anything to the negative of whatever that power is raised to in the denominator. So we see that 1 over a is equal to a to the negative, or let's say we have more generally now 1 over a to the n. That's equal to a to the negative n. So what we can see here is that we have 1 over u to the 1/2, so that must be u to the negative 1/2. So we're just integrating now. So we have x sine inverse sine of x like so, plus 1/2 the integral of u to the negative 1/2 du. Now, negative 1/2 is just a constant, so we have to use, yes, the power rule, our favorite thing to do with integrals. So this is all coming to x multiplied by the inverse sine of x plus 1/2, and let's evaluate this now. So we add 1 to the power and divide by the new power. So we have u to the negative 1/2, then we add 1, which gives us positive 1/2, and you divide by 1/2, which is the same thing as multiplying by 2. So we have 2, then we have u to the, and then our new power is 1/2, of course. Now what we see is that this 1/2 and this 2 cancel super nicely, and what we do to the final step is get back to the x world. So that means replacing u with what x was. So we know that our u was 1 minus x squared. So what we have to see here is that now we have x times the inverse sine of x plus, now we have u to the 1/2, which is u is 1 minus x squared to the 1/2 power, and we are essentially done. And what you can do to make this more nice, we see that raising to the 1/2 is just a square root. So we can write down finally the integral of the inverse sine of x with respect to x is just equal to x multiplied by the inverse sine of x plus the square root of 1 minus x squared plus c. So this is our final answer to this problem. So that was it for today's video, and thank you for watching.